All right, so now we are on example number 4A, which is the last example for section 4.5, which means after this you can do the homework problems if you haven't done so yet, which I'm going to leave as homework for tomorrow during class. So whether you finished it or not, either complete the rest of the work from this week that I've given and obviously complete 1 through 5, upload it. I have to do progress reports for Friday, so make sure you get those in so that I can give you a grade. Obviously, we haven't tested or anything like that, so it'll be solely based on homework assignments, so make sure you get those in. All right, so I'm going to go ahead and get started here. First of all, I'm going to start with the amplitude. The amplitude here is the absolute value of 3. We end up with 3. All right, and again, our new period, since we have k is 2, we end up with 2 pi over 2, which is pi. So this graph here of 3 sine of 2 theta minus pi over 4 is going to complete a cycle between 0 and pi, which we're going to be filling out here. The other new thing here that we haven't seen before is a phase shift. A phase shift is this number here, b, okay? And so b is our phase shift. Okay, and so b equals pi over 4. And because this is negative inside the parentheses, this is going to be a horizontal shift to the right, okay, by pi over 4 radians. So in the end, we're going to be moving the whole graph to the right by pi over 4 radians. We are graphing. There's going to be 4 graphs here in total. So our first graph, I guess I'll put it here, is going to be sine theta. Secondly, we're going to have sine of 2 theta. We're going to have 3 sine of 2 theta. And then finally, we're going to have 3 sine of 2 theta minus pi over 4. Again, I use that prime to indicate that these are the values that we're going to use because that's where these graphs complete their cycle. Sine theta completes its cycle again between 0 and 2 pi. So I'm going to go ahead now and fill in what I know in terms of my table here. So in terms of our table, theta, again, for this one, let me just go ahead and say that this is only going to go between 0 and pi, right? So technically, we're going to be having increments of pi over 4 because we're going to divide pi by 4. And so each of these are going to be added increments of pi over 4, which is obviously going to end at the new phase shift, which is pi. So let me fill this one out. I have space here because there's going to be gaps in between. So for regular sine, we need 0. We need pi over 2. The reason why there's a gap here is because we're going to be using pi over 4 here, which is a half of pi over 2. So technically for this one, we're not going to fill out, but we are going to fill this one out. Next, this one would be the next increment of pi over 4. Which again, it's in the second quadrant. So we don't need that one. We need pi, right? We need 0 to 2 pi. The next one obviously would be in the third quadrant, which is again coterminal to pi over 4, which we don't need because we need 3 pi over 2 for regular sine. And then again here we don't need, and then we end with 2 pi. So this will be for regular sine graph. Now for our other graph, sine of 2 theta, etc., because of the 2, the new period ends at pi. So it's going to be ending right here where this one is, okay? All the rest of these, I'll give you it's determined by the phase shift, which I'll talk about in a moment. So we are going to use 0 because this is from 0 to pi. But if I take pi and again divide it by 4, the next number here, we're going to add pi over 4. Okay, and then we're going to add pi over 4 again. So if I add pi over 4 plus pi over 4, we end up with 2 pi over 4, which if you reduce that, that's just pi over 2. So that's why we get pi over 2. Okay, and then if you take pi over 2 and add pi over 4 to that, and again, work with your fractions here, we end up with 3 pi over 4, which again is in the second quadrant. And then finally, if you add 3 pi over 4 to pi over 4, you end up with 4 pi over 4, which is just pi, and that's why this ends here. Now, this is important, and I guess I will put this in red because in the end, we're going to do the phase shift. Because this is going to be a graph that is horizontally shifted to the right by pi over 4 units, then I'm going to add an additional pi over 4 here. Okay, and it's going to end up, this graph here is going to end up shifting from pi over 4 to pi plus pi over 4, which ends up being 5 pi over 4. Again, when I get back to class, if you're having difficulty with fractions, just let me know so I can show you how did I get 5 pi over 4. Right now, again, I'm just adding them. If you want, you can type it in a calculator, 1 plus 1/4. You end up with 5/4, okay? So again, this is because of the phase shift. I'll call it PS, okay? All right, so for sine theta, I'm going to go ahead and insert the info from here because again, this is just using these numbers here. So at 0, it's 0. At this, we're not using. At pi over 2, it's 1. We're not using. At pi, it's 0. We're not using this one. 3 pi over 2, it's -1. We're not using this one. And then at 2 pi, it's 0. Okay. From there, now for sine of 2 theta, I'm going to be using the theta prime. So I'm going to be using these numbers here. So because sine of 2 theta acts like sine theta, only that it is squeezed between 0 and 5 pi over 4, the values at 0, pi over 4, pi over 2, 3 pi over 4, and pi react as the same numbers as sine of 0, sine of pi over 2, sine of pi, sine of 3 pi over 2, and sine of 2 pi, which happens to be 0, 1, 0, -1, and 0. So at 0, this is going to be 0. At pi over 4, this is going to be 1. Okay, 1. At 3 pi over 4, this is going to be, for this one, it's going to react as a 0 again. Okay. And then at pi, it's going to react, actually, at 3 pi over 4, at pi over 2, it's 0. At 3 pi over 4, it's -1. And then at pi, it's going to go back to 0. So 0, 1, 0, -1, 0, 0, 1, 0, -1, 0. So the same numbers as we get from 0 to 2 pi, we get from 0 to pi. Okay. Now for these here, so we're done with these. We don't need these values because they don't, this one doesn't complete its cycle all the way to 2 pi. It just ends right here. But for 3 pi over 2, remember the 3 is an amplitude. The amplitude means you multiply these by 3. Again, it's a vertical stretch by 3 units. So this is 0. 1 times 3 is 3. 0 times 3 is 0. -1 times 3 is -3. And 0 times 3 is 0. And again, we're not going to use these because there's no phase shift yet. Okay. Finally, at the end, we do have a phase shift. So that's when this red number comes into play. So what the phase shift does is it moves all these numbers over by pi over 4. Okay. So we're going to phase shift pi over 4 units to the right. What that means is this number is going to get shifted here. This number is going to get shifted here. This number is going to get shifted here. And this number is going to get shifted here. And then finally this one here. So at 0, we're not going to have any dot. At pi over 4, that's when our graph is going to start. So I'm going to put 0 is where it starts. At pi over 2, the 3 is going to be shifted downward. At 3 pi over 4, the -3 is going to get shifted downward. The 0 is going to get shifted downward. So at 3 pi over 4, 0 will go here. At at 3 pi over 4, the -3 will be here. And then at finally pi 0 will go here, So again, you're just shifting these by pi over 4 units downward. All right, so with that, we have now enough information to go ahead and graph these. So I'm going to go ahead and take a picture of this. Give me one moment. Let me go ahead and do that. Sorry, my phone is ringing. Let's see if it will do it. Come on. Now it's going to be freezing on me. Let's see if it will do it. New. There we go. All right, so I'm going to take that. I'm going to put it here. All right, so this is our information we're going to graph. Here's the graph we're going to use. I think I could make it a little bit bigger. All right, so here we go. So for our graph, I'm going to go 1 through, it goes 1 through 5, so I'm going to go ahead and put that in. So 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And again, our graph starts from 0 and it goes all the way to 5 pi over 4, okay, because that's where it ends because of the vertical shift, or the horizontal shift to the right. So let me see if I can write this. 5 pi over 4. Again, this is going to be 0 goes first. Pi over 4 is the second one. Pi over 2. 3 pi over 4. Pi. And then finally, the phase shift. I'm going to put a little arrow. This is the phase shift, okay? Where it moves it to the right by pi over 4 units. So I'm going to start with, sorry, I was supposed to make that bigger. I'm going to start with the first one. So the first thing we're going to graph is sine theta. And sine theta, we're only going to be graphing for sine. Technically, did I even put those in there? I don't think I did, but we know the values anyway. So for sine theta, at 0, it's 0. At pi over 2, it's 1. At pi, it's 0. And then, the rest of these at 3 pi over 2, that's not in there. And 2 pi, it's not in there. So I got the number for 5 pi over 4. It estimates at a little bit closer to 1, so it's negative 8.7. It's negative radical 3 over 2. So I'm going to put it like way down here, closer to the negative 1. If this wants to even make a dot, let me see if I can do a dot here and move it. So it's just close to 1, but it's not 1. It's negative radical 3 over 2. So this graph here is the sine graph, and you could see that it's squeezed. Oops. Try that one more time. This is sine theta. Okay. Obviously, the whole graph is not present there because we're only between 0 and 5 pi over 4. So the next one I'm going to graph, I guess I will use that zombie green again. I'm going to be graphing these. So for this one, at 0, it's 0 for sine of 2 pi, or sine of 2 theta. At sine of 2 of pi over 2, where are we? Oh, here. We're using these numbers. Excuse me. Again, it gets confusing. I understand that. So we'll practice more when we get back because there is a review for both of 4.5 and 4.6. So sine of pi over 4 is 1. Sine of 2 times 3 pi over 4, or pi over 2, excuse me, is 0. So that's here. Next, we have sine of 2 times 3 pi over 4 is negative 1. Then we have sine of 2 times pi, which is 0. Okay. And then we can see it looks like the normal sine graph. This one's a little off, but you get the drift here. All right, so look how it reacts like the regular sine graph, because again, it's a whole cycle of sine, but it's again, it has a period of 2 pi over 2, which again is 0 to pi. So this is sine of 2 theta. All right, next I will use, I used orange before. It didn't really pop out that much, so I don't know. Maybe I'll use purple. I don't know if that's too close to blue. I don't know. Maybe we'll try that pink. So this one here, that is 3 sine of 2 theta. That means all we're going to do with this green one is we're going to vertically stretch it out by 3. So these values at 0, it's going to be 0 still. At pi over 4, it's going to be 3. So 1, 2, 3 up here. At pi over 2, that's going to be, basically 0 because it's 0 times 3. At 3 pi over 4, it's going to be negative 3. 1, 2, 3. At pi, it's going to be 0. 0 times 3 is 0. And then finally, that we're done with that one. So this is our vertical stretch of 3 units, or 3 radians. I keep saying units, and these are radians. So this one is 3 sine of 2 theta. Sorry, it's very weird, very light, but there it is. And then finally, we're going to be graphing our function, f of theta. 3 sine of 2 times theta minus pi over 4. Finally, we get to graph our phase shift. All this means is that this the pink graph is going to move this way to the right, okay, by pi over 4 units. So literally this one is going to move to pi over 4. This one is going to move to pi over 2. This one's going to move to 3 pi over 4. This one's going to move to pi, and pi is going to end here at 5 pi over 4. So again, here at pi over, this 0 is going to shift to pi over 4. Okay, that's 0. Next, this one here is going to shift to pi over 2. Okay, and that's 3 at, again, pi over 2. The next one, which is at, where are we? The pink one, it's at 3 pi over 4, is right here. It's going to shift to pi. Okay, so at pi, it is -3. And then finally, the last one, this graph is our phase shift. So finally, this 0 is going to shift here. And we have our final graph. Where did I put it? I think I missed it. Did I miss one? Yeah, this one is here. So, oh, excuse me. I think I messed up. Give me 1 second. Where did I mess up? Let me get my dots again. So this one to here, this one to here, excuse me, this one to here, this one to here, I missed a dot, and then this one to here. So it's easy, again, like I said, to make a mistake here. So here it is. Let me get rid of this pink one. No, that's the graph we were doing. Actually, I need the red one, right? So let me graph this one. I apologize, it's so late, but there it is. Generally, for a problem like this, also, you can look at it on a calculator, only that right now I don't have my calculator with me. So, and Desmos, obviously we can't use it. So I'd like to show the calculator that we have, on the TV at school. So I'm going to have to wait, but there it is. Remember that. Try your best, please. I apologize I'm not there, to answer any questions or anything. But when I get back, I'll answer everything I could possibly answer. At this point, try out the homework problems. So the homework was 4.5, 4.6. Obviously, we haven't done 4.6 yet, but you could try to do 1, 2 says find the amplitude. 3 just says find the amplitude, period, sketch the graph. 4 just says, again, find the amplitude, period, phase shift, and graph 1 complete, period. You could do number 5 because it has cosine. Number 6 because it has sine. And it says viewing rectangle, so you actually have to use a calculator for that, just to take a look at what it looks like on a graph. The rest of them we haven't not gone through, so I will try to get half of those tomorrow or more. I will let you know when I post it. Okay, so your homework for tomorrow, work on number 1 through 6 on the homework assignment 4.5. All right, so that is it for today. I'm going to go back to this and pretty much done. So I'm going to go ahead and put that on YouTube. You'll find all 3 problems there. I hope you have a good night and or a good morning. That'll be for you tomorrow, or afternoon, right? Because I have you for 6. See, my brain's all over the place. Hope to see you soon. All right. Bye.